Hello. So our project is a voice controlled car with collision avoidance. So we like to call a team RoadRash. So the idea is to design a car which can be controlled by a voice. So we plan to implement a voice recognition system which is going to read the commands which are instructed and then control the vehicle accordingly. And then our focus is on ensuring safety. So that is, we are also ensuring that the vehicle is going to be slowed down or stopped when there is any obstacle in the path of the vehicle. So, and because we are implementing this idea using a car based model, we feel that it can be extended to provide a solution for people with disabilities, because we strongly feel that this idea could be extended to the idea of wheelchairs where they could be controlled by the person's voice. So here's a block diagram of the system. The car is driven by four different wheels, in which the first two, the left wheels are connected to one driver unit, and the right wheels are connected to another driver unit, which are in turn controlled by the QTPI 2040. Uh, so we are also using a Pico 4ML board, which is going to detect the user instructions via its microphone and then process the signal accordingly and determine the direction in which the user intends to move it. And we are also using ultrasonic sensors at the front and rear of the system in order to implement the collision avoidance system. And we are also including we also like to use existing battery management solutions in order to ensure the right power is supplied to all components in the system. And the project plan is to implement a voice recognition system in which we are identifying four different commands given by the user. So this specific operation takes place inside the Pico 4ML board, and we also want to use an existing battery management system to ensure that all components get the right quantity of power. And then we would also like to 3D print the body of the car in to design its chassis and mount all the sensors and controllers. And an ultrasound sensor is used to identify the distance from obstacles. And then we also would like to steer the vehicle as per the user's command, that's the user's voice command specifically, and ensure that the vehicle will stop or slow down if there are any obstacles which are detected in a direction of motion.
So the list of components includes 4 DC motors, wheels, motor drivers for both of the set of motors, and ultrasonic sensors for detecting the obstacles, few batteries, the Adafruit QTPI RP2040, a Pico 4ML board with the microphone module on it, a chassis which is 3D printed, and some connecting equipment such as jumpers, sockets, and battery holders. So the challenges and the de-risking methods that we have thought about for this project are: there might be errors in recognizing the command given by the user with respect to the forward, reverse, left, or right commands. So having a robust voice recognition model will help de-risk it. A microphone malfunctioning can also cause an issue. So we are planning to have a backup microphone. So in case the first one fails, the second one will complement for it. Power supply issues. So to mitigate power supply issues, we plan to test the continuity at all the nodes and localize the components so that all components receive power in a unified manner. There might be sensor interference, so we have used the ultrasound sensors. So they are the best ones since they detect the distance based on the reflection of sound. And for an actual implementation of this project on a wheelchair in the real world, LiDAR sensors can be used. So the MVP or checkpoint. So we plan to we plan to implement the microphone which reads all the commands accurately, integration of the voice recognition to the motor drivers, and the 3D printed chassis of the car must be made ready. Circuit design and simulation using Proteus, where any errors with respect to the circuit will be identified, and combining everything together, and we should be able to see that the car runs when the audio is recognized by the Pico 4ML module, and as per the command given, the car should be able to move in the specific direction. The future scope of this project can include capability of the car to turn in any direction at a certain angle specified by the user, integration of a screen where the user can directly input on the screen and that is given directly to the module which drives the motors, and this entire setup can be incorporated in a wheelchair, and EEG can also be used to steer the vehicle accordingly. Thank you.